Lesson 2, here we go. So we're going to be talking about similar polygons. We're kind of continuing building from last lesson a little bit more and adding on and using what we talked about in the last lesson for this lesson, and we're gonna build from there. So if for some reason you'd ever learned about similar figures before, you might be thinking, okay, what is similar figures? What does similar mean? Well, you might be thinking kind of the more generic English term of similar means kind of alike, but not completely alike, right? And that's a good start, but this is geometry, this is math, right? So we need similar in a mathematical sense. So similar polygons, if two polygons are similar, two polygons are similar if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. So this is an example as a triangle, right? And we've also got a little bit of notation here. This symbol that looks like kind of the top of a congruent symbol, that means similar or is similar to or something, or whatever. So similar. Okay. So this says triangle ABCD is similar to triangle DEF, right? And so that is true because angle A is congruent to angle D, angle B is congruent to angle E, angle C is congruent to angle F. So all the angles are congruent and these sides are proportional. So their scale factor, we're going to remember what that is in a minute, but we can set up proportions with any of their sides and it all works, right? Now, I want to note, and we're going to see this throughout the course of this lesson, but I want to note that the order of these letters matter, right? So, A corresponds with D, and B corresponds with E, and C corresponds with F. So even if we turn the triangles or the polygons, they don't have to be triangles, right? Even if we turn them around or reflect them or whatever else, we can still figure out where the corresponding parts are because we can look at the way they're defined, the way they're named, the way they're labeled, right? So that's what similar polygons are. So what is scale factor? So the scale factor between two similar polygons is the fraction, the way they're related. So, and it also matters what direction we're talking about. So like in this example, the scale factor, excuse me, I didn't write this out because I wanted to talk through it. So the scale factor between, that's fine. We can use between. It's more letters. We got this. Between triangle LMN and triangle PRQ would be 9 to 6, right? 9 to 6, which would reduce to 3/2, right? But well, and I'll use different wording on this, more like what's in the book, so we can see, we use different words. But the scale factor of triangle PRQ, so the little one to the big one, of triangle PRQ to triangle LMN is, should put it is up here, right? Is 6 to 9, right? 6 to 9, which would reduce to 2/3. So depending on which direction you're writing the scale factor from, in these cases from big to small or small to big or whatever, it's going to be the same, but the reciprocal of whatever it is, right? And that's that. So the scale factor depends on which direction you're going, right? We'll see that continue to come into play as we do some examples and things. All right, so we've got an example here. We've got a couple of similar trapezoids. We know well, actually, we don't even know they're trapezoids. They I know there are because I drew them, and I know that these lines are actually parallel, but we don't know that. We know they're quadrilaterals, right? We'd have to do a little bit more notating to make them trapezoids. But anyway, quadrilaterals, all we care about in this problem, we don't really care what kind of quadrilateral they are. All we care about is that they are similar, right? And so that is what we're going to figure out, or that information we're going to use to find X and Y. So what we need to do, what's important to kind of do, is to figure out, these two quadrilaterals are not in the same orientation, clearly, right? That is clearly true. And even if it was clear, it'd be a good idea, even if it was clear, as we're going to see in another example later, that it's still important to kind of check and make sure what goes with what. So A corresponds with W, right? So A corresponds with W, so it's flipped around. Let's see if that same idea tracks, right? B corresponds with X, so yeah, it still flips around, right, to there. So this whole, the orientation has flipped around 180 degrees, right? So that's how we can figure out what connects with what. So we need to fit what we need to do in order to solve for X and Y is we need to hopefully find a pair of sides that have numbers that, or have actual numbers without letters in them. So do we have that? Well, AB corresponds with WX, so this 10 isn't particularly helpful with that, right? And did I label something wrong? I kind of made this problem different than, this problem is written wrong. Let me fix it, because this is like X would have been unsolvable. This should be X, right? So this goes with X. It still doesn't help us with what we were trying to find, something with numbers, because we got a letter, right? So what about this 12? Well, the 12, BC is the middle two, so it goes with XY over here. Okay, 12 to 6, right? So 12 to 6. 12 goes with 6. So we've got a workable fraction. 12 to 6. We can reduce that down to the scale factor. We're not really asked to do that on this particular problem, but we can. So if we reduce that as the scale factor of 2, right? That's a nice scale factor, right? Because 12 divided by 6 is 2, right? Or 2 to 1. That's handy, right? So that goes. We already labeled one, or we already saw one. Now that we found one with numbers on it, then I'm just going to rewrite this in here. Now that we found one with numbers on it, we can kind of get this party started. We already said AB goes with XW, right? Because AB goes with XW or WX, right? So we can put 10 to X. Oh, that's already, look at that. We're already seeing something that's going to be nice and clean and simple and beautiful, all of those things. Let's keep on going around. We've got 9, this AD. So AD, so that's these two outside edges, so that should be WZ. Where's WZ? So WZ is this one. So AD goes with 3y minus 1. So this equals 9 to 3y minus 1. So we've got this kind of big old set of proportional things happening here. We just need to take and pull out some versions of it that let us go. Let's take this reduced scale factor version of this one, because that's going to be nice. So to find X, we can use the proportion 2 to 1 equals 10 to X. That's easy to solve, real easy, right? 2 times X is 2X equals 1 times 10, which is 10. We divide by 2. A lot of you could probably do this particular proportion all in your head, right? Easy peasy. So X equals 5. No big deal, right? So what about the Y, right? So we want to go back. We want to use that as one of them. So we know we want to use the 9 to 3y minus 1. Which other fraction we use? Any of the other fractions that have just numbers on them will let us get there. So we could use 12 or 6, or we could keep using the reduced one. That's kind of nice, right? So let's use the 2 to 1. There we go. So now we're going to cross multiply again. So 2 times 3y minus 1. I'm going to write that all the way out because we got to remember that you have to distribute that 2. Es muy importante, right? 3y minus 1 equals 1 times 9 is 9. So we're going to distribute this 2. Kind of running out of room down here. I'm going to kind of move this. I'm going to move this up to here, right? That seems reasonable. 2 times 3y is 6y. 2 times negative 1 is minus 2 or negative 2, right? Same thing. Plus a negative is the same thing as subtracting. Equals 9. Now we're going to continue to solve. So we're going to add 2 to both sides. Plus 2, plus 2. And then we've got 6y equals 11, right? So we're going to divide by 6. Divide by 6. So y equals 11 sixths. Great. All right, we got one more little concept here and then another example, and then we're done. All right, so the last concept that we're going to hit in this lesson is that perimeters of similar polygons have a proportional relationship. So if two polygons are similar, then their perimeters are proportional to the scale factor between them. So that reduced, well, even the not reduced fraction, we just usually write scale factor as a reduced fraction. But so the perimeters, this notation here is a little bit kind of confusing looking, right? But it's pretty straightforward. If ABCD, so this quadrilateral, is similar to JKLM, so this quadrilateral, then their perimeters, because how do you find perimeters? You add up all the sides. That's what this would be for the big triangle. And this would be adding up all the sides for the small triangle, right? This side plus this side plus this side plus this side, et cetera, right? Easy peasy. Equals their scale factor. And this is their scale factor written out 4 ways, right? All right, the AB, the measure of AB to the measure of JK, and for all of the sides. These are necessary and unnecessary depending on how you're looking at it, but it's there because these are going to be all equivalent, right? Which, that's what equals mean. Let's put some meat on this, do an example so we can get things going. So if ABCDE, we got a pentagon here, is similar to PQRST, find the scale factor of ABCDE to PQRST. So this one to this one, right? And the perimeter of each polygon. All right. So just like all of the best geometry problems, we've got a puzzle happening here. So taking a look at these shapes, let's kind of fill in some of the gaps that this problem leaves blank, right? We've got tick marks here, right? So that means that we can say this is also 4. This is also this is also 8. This is also 3, right? Okay, so that's those all go together. That's great. Now let's kind of figure out the orientation. Make sure it looks like, just looking at this, that this A goes with R and C goes with P. But if you look at the order of our letters, that's not actually correct. A goes with P and Q. Well, Q obviously. B goes with Q. Like that's the same. But R and C go together. So these two, their orientation have reflected, right? So they're reflected. So this 3 here actually goes with this 4 here. So the scale factor, to answer that first part of this question, the scale factor equals 4 to 3. It's 4/3, right? There's the scale factor. All right, so then we got to find the perimeter. So the perimeter is proportional to the scale factor. So this one, we don't have all the puzzle pieces, so we can't find its perimeter by itself. This one, we can. So to find the perimeter of this guy, this one, it would be all of these sides added up. So the big this perimeter here would be 8 plus 8 plus 4 plus 4 plus 6. There's 2 8s, so I'm going to write it like this. The perimeter. I'm going to put a perimeter sub L for the left one. Seems reasonable, right? So would be 2 times 8 plus 2 times 4 plus 6. I'm going to go ahead and walk this down. That way, if I make mistakes, you can laugh at me. It'll be fine. 2 times 8 is 16. 2 times 4 is 8 plus 6. I'm going to do 8 plus 6. So 16 plus 14, which tells us that the perimeter over here is 30. Does that match the notes I have? Let's find out. Just because we're curious. Over here it does. Look at that. So the perimeters are proportional. So this perimeter to the perimeter of the other one, let's call that P sub R for the perimeter of the right one, equals the scale factor. So equals 4/3, or is proportional to the scale factor, I should say. Right? There we go. We got a proportion. Let's solve the thing. Cross multiply. 30 times 3 is 90. Equals 4 times P sub R is 4P sub R. Get rid of the 4 by dividing. So I'm going to divide both sides by 4. So P sub R, the perimeter we're looking for, P sub R is 90 divided by 4, which would be 45 divided by 2, which is a fraction. I've got it here. Yeah, I would have got there. It's getting late. I'm tired. I didn't get enough sleep last night. All the things, all the layers. 22.5. And that's it for this lesson. If you're one of my students, I'll see you in class. Do your homework. All of those things. If you're not one of my students, thanks for joining us. Hopefully this has been helpful to you. We'll catch you in the next one. Bye-bye.